Good morning, grade 9. Our new lesson today, Algebra 2, Chapter 5, Lesson 2. Multiplying and dividing rational expressions. Multiplying and dividing rational expressions. Okay, you have worked with inverse variation functions such as y is equal to 5 over x. The expression on the right side of this equation is a rational expression, 5 over x. A rational expression is a quotient of two polynomials. Other examples of rational expressions include the following: x squared minus 4 over x plus 2, or 10 over x squared minus 6, or x plus 3 over x minus 7. Because rational expressions are ratios of polynomials, you can simplify them the same way as you simplify fractions. Recall that to write a fraction in simplest form, you can divide out common factors in the numerator and denominator, like 9 over 24. 9 is 3 multiply 3, and 24 is 8 multiply 3, so I can cross out 3 and 3, 3 in the numerator and 3 in the denominator, so I will get out 3 over 8. Like simplifying rational expressions, simplify, identify any x values for which the expression is undefined, like 3x squared, 3x to the power 7 over 2x to the power 4. When I want to divide the exponents, I subtract them. If I want to divide exponents, x to the power 7 and x to the power 4, I divide them. So x to the power 7 divided by x to the power 4, I divide them. So it will be x to the power 7 minus 4, so it will be x to the power 3. So now I simplify the two exponents here. 3 over 2, I cannot simplify them, they are already simplified. So the simplest form for 3x to the power 7 over 2x to the power 4 is 3 over 2x to the power 3. The expression is undefined at x is equal to 0 because this value of x makes 2x to the power 4 equals to 0. Again, I have another example. X squared minus 2x minus 3 over x squared plus 5x plus 4. How I can simplify this? I can simplify by factoring. By what? By factoring. I will factor the numerator and I will factor the denominator and I will cross what is common. So x squared. You remember when we used to say, like here, minus negative 3. Negative 3. Which two factors that can be multiplied by negative 3? Two factors. When I multiply them together, they will give me negative 3. And when I add them together, they will give me here negative 2. It is negative 3, and positive 1. Because when I multiply negative 3 and positive 1 together, they will give me negative 3. And when I add negative 3 and positive 1, they will give me negative 2. This part. So now I'm going to factor x So now I'm going to factor x minus 3 and x plus 1, and in the denominator I'm going to repeat the same steps. The same steps are 4 here, 4. Which two factors, when I multiply them, they will give me 4, and when I add them, they will give me the middle term, which is 5. They are 4 and 1. So I'm going to factor down x plus 1 and x plus 4. So up in the numerator and down in the denominator, I have a common x plus 1. So I'm going to cross them. So they will be left here x minus 3 and x plus 4. So the steps are factor, then divide out common factors. The expression is undefined as x is -1 and x is -4 because these values of the x negative factors x plus 1 and x plus 4 equals to 0. Okay, let's watch here a video.
Around us in mathematics, in science, in life. So it's important to be able to take a look at a rational expression. Rational expressions occur all around us in mathematics, in science, in life. So it's important to be able to take a look at a rational expression and, when we can, simplify it. Let's take a look at an example. 3t to the 4th divided by 15t. How can we simplify it? Well, it's plain that we can actually divide the numerator and denominator by 3 to get a simplification of the coefficients. So we just are left with 5 downstairs in the denominator. But we can also simplify some of the t's. Do you see that? Because here I have t to the 4th, which means t times t times t times t, and I have a t downstairs. I can divide the numerator and denominator by 1t. Or you can also remember the laws of exponents. This is actually going to be t to the 4 minus 1 in the exponent, which is t cubed. So in fact, when I make the cancellation, I can think about just reducing this 4 to 3 because I've got a 1t downstairs. When I do that, I get an answer of t cubed over 5, which seems pretty happy, except to remember something important about the original expression that this expression now lacks. Namely, in its denominator, originally we had a t. That means that there's a particular value of t that we are not permitted to put into this expression. And what is that value? Well, plainly, whatever makes the denominator 0. Well, if I have 15t equals 0, the only way that can happen is if t is 0. So t is not allowed to be 0. And that has to follow through even in this case here. Even though here, by itself, we can plug in t equals 0, we know that really we're not allowed to. So I have to put in a proviso that t cannot equal 0. And if I do that, then I can say that this equals that. So the important thing to remember is, if you simplify, you've got to make sure that if you're canceling out some variables, that you're not accidentally losing the fact that some of those variables can't be 0, or some of those values cannot make the denominator equal to 0. Let's take a look at another example. 2 together. Here's a rational expression. It's a quadratic divided by a quadratic. And let's see if we can simplify. Now, it's not clear how to simplify this automatically. So the thing to do is to see if I can factor. Always the key to this business is factoring. When you can factor, then we're golden. If you can't factor, then we are up the mathematical creek without a mathematical paddle. Well, the numerator, you'll notice, is the difference of two perfect squares. And so I automatically know that can be factored as x plus 5 times x minus 5. And you can actually check that out with a little FOIL. And you can actually see that the outside terms and the inside terms add to give 0. So I'm left with just x squared minus 25. Bang. All right, if I factor the denominator, how can I factor that? Well, I'm going to put an x here and x here. This tells me I'm going to have opposite signs because it's negative. For a positive, I'd have the same sign. And I need two numbers whose product is 10, and when I subtract them, I get 3 and negative 3 actually, so I'm going to put the 5 here and a 2 here. Check it out. Negative 5x plus 2x is negative 3x, and that's negative 10 when I take the product. Excellent. Now I look at this. Can I simplify? Sure, because I can cancel here. this factor and this factor actually can be simplified and cancel away. So I'm left with just the numerator that's left over, x plus 5, divided by the denominator. That seems great, but to make this really equal, I've got to make sure that I don't accidentally plug in things that would make things go bad. Well, it's plain that the value for x that makes this go bad is when the denominator is 0, which means x equals -2. So x cannot equal -2. But if you go back to the original one, which I have here, we see that also x cannot equal 5. Because if I plug in 5, you see I'd have a 0 in the denominator. So you always have to make sure that if you're canceling things away, you're not actually introducing some bad stuff. So I have to say x can't equal 5 as well. And so what I see here is that this rational expression equals this rational expression under the understanding that x cannot equal -2 and x cannot equal 5. Got to be really careful you don't accidentally cancel away some dangerous points.